So this question wants us to describe the conditions for each of these cases. We have a situation where a rational function has a horizontal asymptote of y equals 0, also known as the x-axis. A rational function with a non-zero horizontal asymptote, so a different type of horizontal asymptote. A rational function with a slant asymptote. A rational function that has neither a slant asymptote nor a horizontal asymptote. And finally, a rational function with a hole at x equals 2. To answer this question, we need to talk about rational functions and their degrees. So a reminder, a rational function, r of x, is p of x over q of x, where p of x and q of x are polynomials. Where p of x, q of x, and p of x are polynomials. Right? And of course, q of x can't be 0. That's important for us to know. So what are polynomials? For example, p of x could be a0 plus a1x plus a2x squared plus dot 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 plus 8nx to the n. Normally speaking, we put the highest power first. I switch the order here just to make a point here. And q of x could be thought of as b0 plus b1x plus b2x squared plus dot 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 plus b sub k x to the k. So the highest power of the top is n, the highest power of the bottom is k. That's called the degree. So the highest power is the degree of the polynomial. So in my example, P has degree n and Q has degree k. So it is the degrees that tell us things about horizontal asymptotes. So if we go back and look at the question, what does it say? A rational function has a horizontal asymptote of 0. What does that mean? When does that happen? Well, that occurs if the degree of the denominator is greater than the degree of the numerator. So whenever that happens, if you have a higher power downstairs, right, you will have a horizontal asymptote at y equals 0. We could look at an example. Let me go ahead and load Desmos. Just showing you that if the degree of the bottom is bigger, we'll get there. So, for example, the degree of the top, make the degree of the top maybe x plus 5, so the degree of the top is 1. The degree of the bottom, fine, good enough, x squared minus 6x plus 8. The degree of the top is 1, the degree of the bottom is 2, horizontal asymptote at y equals 0. So you can see that as the function moves on, that's the case. If I change the degree of the top to be the same, I have a different horizontal asymptote, no longer. But if the degree of the bottom is bigger than the degree of the top, then I always have a horizontal asymptote at y equals 0. What is our next question? The rational function has a non-zero horizontal asymptote. That means the degree of the denominator is the same as the degree of the numerator. And then we divide those out. So the degree of the denominator is the same as the degree of the numerator. So if we look at Desmos, if we make them the same, so I have x squared plus 5 upstairs. If I make it x squared minus 6x plus 8, I have a horizontal asymptote at 1x squared at y equals 1. So we can see that here at y equals 1. A little difficult to see, but if I move it out, you'll notice how eventually the graph gets closer and closer to 1 on this side. Eventually the graph gets closer and closer to 1. If I have a 3, right, 3x squared over 1x squared, and y equals 3 is my horizontal asymptote. Again, a little difficult to see. But you can see as you move out, the graph gets closer and closer and closer to 3. I can, of course, change this from that to maybe negative 100 to 100. And you'll see that the value 3 here, indeed is the long-term behavior of that function. All right, what is next? The rational function has a slant asymptote. Well, in that situation, the degree of the numerator is 1 higher than the degree of the denominator. That the degree of the top is exactly 1 more than the degree of the bottom. So we can look at that situation, 1 more. So right now I have x squared up top. If I put the bottom just an x, like 2x plus 1, I should see a slant asymptote. And I can, again, see how that's heading that way. That's heading that way. So it's going to be difficult to see. But you can see there's our slant asymptote coming in that situation if the degree of the top is 1 more. Changing the numbers, negative 5x cubed plus x squared. Now it's 2 more, no longer a slant asymptote. But if I can make it 1 more, so now the degree of the top is 3, the degree of the bottom is 2, you'll notice I have another slant asymptote coming in there. It looks like a line, an oblique line, as I head away from the origin. Okay. And what next? A rational function has neither a slant asymptote nor a horizontal asymptote. And then for that one, the degree of the numerator is more than 1. Is more than 1 higher. Than the degree of the denominator. If the degree of the numerator is more than 1 higher than the degree of the denominator, then that's going to happen. So we sort of looked at that on Desmos. We can look at it again. You're going to have neither situation. So right now it's 1 higher. If I change it, the degree of the top is 3. Now the degree of the bottom is 1. Something strange is happening here. I'm not sure what that is. X plus 5. Okay, so you can see that there is no slant asymptote here. Although if I make it x squared plus 5, then they're going to be a little difficult to see. But that's our situation. And then finally, our question says, what happens when we have a whole? Well, basically, I need x minus 2 to divide out of the numerator and denominator, right? So that's going to happen if x minus 2 cancels. So it divides out of the numerator and denominator. Difficult to see on Desmos, so I'll go ahead and I'll show you that on the graphing calculator to see how that works. So if I have an x minus 2 that divides out top and bottom, so I might have up top x plus 4 times x minus 2 divided by parentheses. I want the x minus 2 to divide out. Right, so you see we have an x minus 2 upstairs and downstairs times, I don't know, x plus 1. If this happens, then I should have a whole at x equals 2. We'll try zoom decimal first, and I'll adjust the y's if I have to. Can they see what happens? There you go. There's your whole at 2 because x minus 2 divided out.